Okay, here is a hyperbolic identity that we're supposed to prove, which is a little bit more complicated than the other ones that we've encountered. And it turns out there's two ways to go about this, a long way and definitely a shorter way. Let's take the longer way first. Up here we have 1 plus the hyperbolic sine of 2a plus the hyperbolic cosine of 2a. And what we were thinking of is, can we use one of our identities here that will cancel out this 1? Because there are several different ways of writing out the hyperbolic cosine when you have two times a function. There's several identities involved. One of them is, let's see, the hyperbolic cosine of 2x equals 2 times the hyperbolic square root of x minus 1. So if we replaced this for this, these 1's here would cancel out. And then down here we have minus the hyperbolic cosine of 2a. And there's yet another identity involving this. And that is 2 times the hyperbolic square root of x plus 1. So if we had minus this term, we have minus this, minus 1, and those ones would cancel out. So that was kind of our method of attack. And both of these now identities we had covered in our introduction video, the hyperbolic functions. So let's rewrite this expression. Here we have 1 plus hyperbolic sine of 2a plus this, which now we're rewriting as this. So this would be 2 hyperbolic square root of a minus 1 divided by 1 minus this. And now for this, it's going to be minus this minus this. So minus 2 minus 1. And these drop out. We've got two negative signs down here, so let's write it like this. Hyperbolic sine of 2a plus 2 times hyperbolic cosine square root of a divided by minus hyperbolic sine of 2a plus 2 hyperbolic squared of a. And since we have this in the top and bottom terms, we went ahead and divided everything by it, so this equals minus 1 plus 2 times the hyperbolic square root of a divided by this. And down here we have 1 plus this divided by the hyperbolic sine of 2a. And then here's where this becomes helpful at this juncture to recall that the hyperbolic sine of 2a equals 2 hyperbolic cosine of A times the hyperbolic sine of A. So we can rewrite this as 2 times hyperbolic sine of A, hyperbolic sine of A times the hyperbolic cosine of A, and same thing here, 2 hyperbolic cosine of A times the hyperbolic sine of A. So what does this give us? We have equals minus 1 plus these two cancel, this and this will cancel, so I have hyperbolic cosine of A divided by the hyperbolic sine of A, and down here we have 1 plus these twos cancel, and this cancel, so I have the hyperbolic sine of A divided by the hyperbolic cosine of A. And we could write this as 1 plus the hyperbolic cotangent divided by 1 plus the hyperbolic tangent. That didn't get us anywhere. That just appeared to be kind of a dead end. So I went ahead and added these two terms and added these two terms. Let's just make some room for that. So this equals up here we'll have hyperbolic sine of A plus the hyperbolic cosine of A divided by the hyperbolic sine of A. And down here we have hyperbolic cosine of A plus hyperbolic sine of A divided by the hyperbolic cosine of A. Hopefully you can see where this is going by now. Let's just invert and multiply. That will equal minus this here, this plus the hyperbolic cosine of A divided by hyperbolic sine of A times the reciprocal of this, and these cross out, obviously. So we have the hyperbolic cosine divided by the hyperbolic sine. That's the hyperbolic cotangent with the minus sign before it. And that's what we were supposed to show here. So it was a little bit convoluted. The thinking was, or the initial thinking anyway, was trying to replace this using one of our identities to get the ones to cancel out, and same thing down here. Then we were working strictly with just hyperbolic functions, and after that we could manipulate it from there. Now that turns out to be of the two ways that we can go about this. This turns out to be the longer way. The shorter way is we went ahead and just started, like I said, invoking identities to try to get rid of these ones here. What would happen, though, if we just used our basic definitions? And if you use the basic definition for the hyperbolic sine of 2a and the hyperbolic cosine of 2a in the numerator and the denominator, this expression right here comes out to equal 1 plus e to the 2a on top divided by 1 minus e to the 2a on bottom. Use a basic definition and it comes right out. Okay, but what do we do with this? Now here's where we have to use our imaginations. If we could say, if we could multiply this by an e to the minus a on top, and this would give us an e to the minus a plus an e to the a, that would look like it might get us a hyperbolic function. But if we multiply the top by this, we could write this a little bit neater, by e to the minus a, then we also have to multiply the bottom by e to the minus a, so we're multiplying this entire expression by 1, so that's valid. So if we do that, now where do we end up? Now we have e to the minus a plus e to the a, and down here we have e to the minus a, and here we have minus e to the a. Well, if this was a hyperbolic cosine divided by a hyperbolic sine, the 2's in the denominator of each one would cancel out, and we would have this, but this right here would be a minus hyperbolic sine. Let's just write it like this to make it more clear. Suppose we multiply top and bottom by 1/2. So here we would have e to the a plus e to the minus a divided by 2 divided by e to the minus a minus e to the a divided by 2. Well, this, of course, is just the hyperbolic cosine of a, and this here, this is minus the hyperbolic sine of a. If this was e to the a minus e to the minus a, that would be the hyperbolic sine. If we turn it around, this is minus the hyperbolic sine here, so this equals minus the hyperbolic cotangent. It just falls right out. So definitely, this is the shorter way to go about it, just using our basic definitions so that this becomes this. But once we get it into this expression, here's where we have to use our imaginations a little bit. 1 plus e to the 2a, and you have to think, well, if I could multiply this by something so that we would have this raised e to an a power, and this would be e to some power, then it might work out for us. So what do we have to multiply it by? Well, multiplying by e to the minus a would work. Obviously, though, if we multiply the numerator by this, then we have to multiply the denominator by it, which was fine because it set us up. In fact, you just might be able to look at the problem right at this point here and realize that would be a plus hyperbolic cosine, and this would be a minus hyperbolic sine. We went ahead and divided top and bottom by 1/2 just to make it explicit here. But that's it. This is definitely the shorter way to go.